Welcome to the lecture series of Basic Electrical Engineering. Now we are seeing the module 5, that is Electrical Utilities and Production. In that we are going to see today is that is electrical tariff, desirable characteristics of tariff and types of tariff in detail. So in this first, we want to concentrate what is meant by tariff. So I think we might have got some idea regarding tariff. Uh, it is based on money of the energy consumption. So we consume energy based on that what we are going to pay. That is known as generally in tariff. This is applicable for taxes also. So what is the product? What is the income? What is the rate at which it is sold to the consumer? That is the basic tariff. Here we are going to talk about the electrical tariff. So what is meant by electrical tariff and how it has an impact on the various consumers. So that is also one more key point we are going to discuss here. So first, we are going to see the definition of a tariff. So tariff is nothing but the rate at which the electrical energy is supplied to the consumer. The rate means the rupees. The rupees at which the electrical energy is supplied to the consumer is known as tariff. In simple, so every month we are paying the BESCOM bill, and the BESCOM bill it has some value, maybe some 800 to 1000 rupees. It is based on the number of units consumed by the particular consumer. So based on that, we are paying the tariff amount. So that electricity bill is basically a tariff. It is derived from some factors. So that we are going to see now. So in other terms, definition of a tariff is total actual energy charges, that is fixed plus running, divided by total energy supplied to the consumer. So that is the other definition of a tariff. So what is the fixed charges and what is the running charges that may be derived by the proper EB company. Here it is our Bangalore Electricity Company, so BESCOM. Similarly, for other states, there may be their particular electrical suppliers. Based on that, they may be fixed their rates, and based on the unit consumption, it may be charged. So basically, there are three types of tariff, that is residential, commercial and industrial. So residential is nothing but the domestic. So what we are using in our residence is known as the residential tariff. Commercial is little bit different and it has more price too. For example, in malls, theaters and some entertaining spots, so it has a different tariff according to the consumption. Similarly, industrial consumers such as big and small scale industries, large scale and small scale industries have different tariff. So based on the tariff, he has to pay the amount of energy consumed. So what is the objective of the tariff? So the main objective of the tariff is recovery of cost producing electrical energy at the power station. Why we want to put a tariff or a EB bill? So we are consuming the energy that is getting from the some energy station. I think we might have seen in the previous lecture, that is how the energy is generated. For that, raw materials, running cost, capital cost, everything is there. So we have to recover from the tariff only. Then second one is recovery of cost on the capital investment. So what I told already, capital investment for the generating station, capital investment for transmission and capital investment for distribution systems. So these and all we might have studied in the single line diagrams. For all this we have to pay. And the third one is a recovery of cost of operation and maintenance of the supply of electrical energy. For example, metering equipment, billing equipment, and also we have the running cost. So and also maintenance. So if for example in rainy seasons we may get frequent power cuts, so we have to invest on that for that maintenance. And the maintenance people also we have to pay the money. And for also the paying the people who are working in the power station, discom, all we have to pay. So for that purpose we are putting the tariff on them. And also the last one is the suitable profit on the capital investment. So it should not be a social type of industry. It is a consumer friendly, but it is not a non-profit organization. It is a profit organization. It should have some profit for further extension of the plants. So if you want to open one more power plant, for example, there may be thermal power station one. If the profit is there, we can go for one more station and we can produce additional power. So it is a basically a profit organization. So we are coming for the characteristics of the tariff, desirable characters of the tariff. So, what are the character should a tariff possess? That we are going to discuss now. The first one is proper return. That is, the tariff should be such that it ensures the proper return from each consumer. So, in other words, we can say that total receipts from the consumer must be equal to the cost of producing and supplying electrical energy plus reasonable profit. So, it should have the proper return. So once again, I can reproduce that. That is, one is the cost of producing the electricity. Second one is cost of supplying that same electricity with some reasonable profit. So it should have the proper uh, returns so that it will have some reasonable profit also, and it can produce reliable service to the consumers. Next one is the fairness. What is meant by fairness? The tariff must be so that different type of consumer are satisfied with the rate of charge of electrical energy. In case of your smaller consumer, you should be charged with your level. In case of bulky or bigger customer, you should be charged with their perception. For example, the big customer should be charged at the lower rate than the smaller customer, and it is because the increased energy consumption. So bigger consumers should get some incentive, and uh, for other additional projects you should get some different type of tariff. And also a consumer whose load condition do not deviate from the ideal, that is non-variable, such customers can also be charged with low levels. And the third point is simplicity. So the tariff should be simple so that ordinary people can easily understand. It should not be complicated. For example, like integration formula, it should not be. So it should be easily understood with simple formulas, or a plus b plus c, or what is what. So or what is the fixed cost, what is the running cost, like that we have to make a tariff. It should be easily understood by all. So it should not be a complicated one. And next one, it should have a reasonable profit. This already we discussed. The profit of the element and the tariff should be reasonable, because it is a public utility company. We know already it is a government organization, and it generally enjoys the benefit of the monopoly. So the investment should be relatively safe due to non-competition in the market. So there is only one energy supplier for all over Bangalore, that is Bescom, not the other one. So he should have some reasonable profit. He should not, because he is the monopoly, he should not enjoy all the provisions given to him, and or he should not attract more profit on that, because it is as a government based organization. Then it should be attractive. Attractive in the sense the tariff should be so large number of consumers are encouraged to use the electrical energy, so they should be attracted towards that, and effort should be made to fix the tariff in such a way that consumer can pay easily. So now we can pay it easily through online, through many apps we can do. So, and also it is attracting larger by using some beneficial discounts we should give for some consumers also at time to time. So, for example, during the COVID time, we should give some relaxation like that. So, we should make them attractive. And now we are going to see the factors affecting the tariff. So, what are all the factors? How the factor can be managed, or how it is affected. So, here type of load. Based on the load, the tariff, that is the bill, may be affected. Maybe always we are in residential purpose, we are using only one type of load, that is maybe the resistive load. Some case we are using the inductive load. So based on the load, the tariff may increase or decrease. And also based on the maximum demand. This is particularly for industry. What is the maximum demand? So based on that, the tariff may differ. And time at which the load is required. For example, in electrical terms, there are two peak hours, that is morning 6 to 9 and the evening 6 to 9 is the peak hours. At the time, if you consume power, so at the time they may fix more power, more charges for power consumption. And if you are using, they will encourage if you are using non-peak loads, that is from 9 to 12 you can use, but generally we won't use. But it is encouraged so that there will not be a big hit in the generator, may not be overloaded, so that it cannot be overloaded, means that is each maintenance will be very less. And also the power factors of the load, this is very very important. So here the power factor of the load should be very less. So the power factor of the load should be very less is in the sense it should be in the unity power factor or maximum zero point 0.8 to 1 is encouraged. So lagging power factor causes penalty, that is attracts more cost in the tariff. Then amount of energy used, this is directly proportional. So what are the unit consumed, you have to pay the bill for it. So these are all the factors generally affecting the tariff. Now we are going to see about the types of tariff. So there are different type of tariffs employed. Some basic types we are going to see now. One is the simple tariff. Second one is the flat rate tariff. Third one is the block rate tariff. Next one is the two-part tariff. Next one is the maximum demand tariff, and based on the power factor tariff and three-part tariff. So these are all the various type of tariff employed for electrical bills. So how it can be explained, we will see one by one in each slides. So here, first one we are going to see about the simple tariff. So simple tariff, in other words, it is known as uniform rate tariff. So here, when there is a fixed rate per unit of energy consumed, it is called simple rate tariff or uniform rate tariff. Here you can see the charges is fixed as per the unit consumed, it's directly proportional. So per unit, it doesn't vary with increase or decrease in the number of units. As long as you increase the number of kilowatt hour or energy consumed, as long as the charges will increase, it is linear. So here the consumption of electrical energy at the consumer is recorded by an energy meter. Based on the energy meter reading only, we are going to impose the tax or bill on the consumer. So this is the simplest of all tariff, and it readily understood by all the consumers. There is no complication. It is actually linear. But what are all the advantages and disadvantages of simple tariff that we are going to see now? So it is the simplest method of tariff, and it is easily understand and easy to apply for all, and each consumer has to pay according to their utilization. So they need not to pay extra or less. What is their utilization, they have to pay. That's why the curve was linear. And disadvantages is there is no discrimination according to the different type of consumers. So some differentiation should be shown for different type of consumers. If everybody is same using the or if everybody are paying the same bill, means there is no difference at all. So we should show some discrimination. And cost per unit is high. Here we impose this tariff for all. The cost per unit generation is very very high, and there is no incentives. I told already in the factors or what is the characteristics of tariff, we told already it should be attractive. So we should give some incentives based on their consumption and based on the consumer. So that is not in this type of tariff. And if a consumer does not any consume does not any energy in particular month, the supplier cannot charge any money. So this is very very uh, not proper, right? So because if you're not consuming energy, you will not pay bill, so there will be a loss in that. So it should not be encouraged. So where it is applied is generally applied to for irrigation or agriculture purpose. Only for irrigation they are using this tariff. It cannot be implemented everywhere because of more drawbacks are there. So the next one we are going to see is the flat rate tariff. In this tariff, different type of consumers are charged at different rates of per unit cost of energy consumed. Different types of consumer, how they are grouped. So under different type of category, each category has a fixed rate similar to the simple tariff. For example, category 1 will have one type of tariff, category 2 will have the different type of tariff. So according to the type of load and type of consumer and load factors, so there will be different category, and different category has a different charges. So here we'll take one example. So for a lighting load, that is if you are using only lighting load in a house, you doesn't have any motors or any heaters, only you are using lighting load, that is only lights, tube lights, or maybe CFL lamps, or maybe incandescent lamp, they may charge 60 pice per kilowatt hour. In case of you are using a power load, so this is a charge is very less. So we'll consider charges the category 3. So they will cost 60 pice per kilowatt hour. But in case of you are using the power load, that is if in case of you are using motors and in case of you are using heaters, so it is sold for 55 pice per kilowatt hour. So there is a deviation between these two. Okay, so this is the about the flat rate tariff. In simple, each category of consumer will have each category of prices for per unit. So it may differ. So here you can see. So this is the fixed charges, variable charges, plus tax plus penalty. So these are best combo. So this is the fixed charges. And these are all the variable charges for variable power factor and all. Then taxes means taxes. So these are BESCOM bill. This will be discussing in next topic also in detail. So what are the advantage of this one? So of the flat rate tariff. So sorry. So here it's more fair to different consumers and simple calculation. As we told, one group of consumers will have one value. But here, some drawbacks also there. A particular consumer is charged at a particular rate, but there is no incentive for the consumer. So that is a big drawback. We should keep that. And the second drawback is since different rates are decided according to different loads, separate meter need to be installed for different loads. So that is one more drawback. For example, I give an example light load and power load. So for these type of load, we should use a different meter. I think we maybe study this energy meter in the next module. And next one is the power load. For that, we should put a separate energy meter. So we should install. Installing cost is expensive in that, and it's complicated. We have to identify them and we have to install them. And all the consumers are in a particular category are charged at same rate. However, it is not fair if the consumer that utilize more energy can be charged for low fixed rate. So they will consume more energy in low fixed rate. So the categorization is not proper. So this is a little bit difficult, but generally it is applicable for all domestic. So domestic means in our house also it is consumed. That's why I showed in the previous case. So that is the fixed charge and the variable charge. Next one is the block rate tariff. So here, when a given block of energy is charged at specified rate and the succeeding blocks of energy are charged at progressively reduced rate, it is known as block rate tariff. So how can we explain this? So in block rate tariff, the energy consumption is divided into blocks and the price per unit is fixed in each blocks. So for example, the price per unit of the first block is the highest one. So we will have one graph in that first block will be highest one and progressively reduced by succeeding blocks of the energy. For example, the first maybe having 30 units may be charged at 60 paise per unit. The next 25 units will be charged at the rate of 55 pice per unit, and the remaining additional units may be charged at the rate of 30 pice per unit. So first block has more, second block is little bit less, third is very less. So like that. So this is the next type of tariff, that is the block rate tariff. So they are dividing. Here you can see. So first block, second block, and third block. So based on this, the total energy consumption based on the total charges will be derived. So what are all the advantages of this? Only one energy meter is required, that is fine. Incentives are provided for consumers due to reduced rate and consumer use more energy. This improves the load factor and reduces the cost of generation. So we can provide incentive because we have different blocks. If the consumer does not consume any energy in particular month, the supplier does not charge any money, even though the connection is provided to the consumer as its own cost. So that is a big drawback, and it can be applied for all residential and small commercial consumers. So who are all the commercial consumers, we can apply this tariff. For example, in theaters or malls, we can apply this tariff. Next one is the two-part tariff. So here in the title itself we have got the idea about the tariff. Here there is two parts. So when the rate of electrical energy is charged on basis of maximum demand of the consumer and the units consumed, it is called as a two-part tariff. So here these two. So here B into kilowatt. B is nothing but the maximum demand in kilowatt plus charge per kilowatt. So here two rates are there. One is the for one amount for the maximum demand and the other amount is for the total unit consumption. So based on this, the energy will be calculated. So this concept we can understand in the problems. We are going to do the problems based on this. So in this topic we can able to understand that. Here this tariff is mostly applicable to industrial consumers, as I told already, who have the maximum demand. Maximum demand is, for example, if there are 24 hours, they may consume maximum value of the load or maximum amount of kW kilowatt at particular time. So that for that they will charge for that maximum demand and they will keep it as a reference. Based on that they will charge. So that is known as, while doing the problem we may get a clear idea. So here what is the advantage? If a consumer does not any energy, so in particular month, the supplier will get the return equal to the fixed. So he will get the returns, the fixed charges equal to the fixed charges, they will get a return. But the drawback is, even if a consumer does not use any electricity, he has to pay the fixed charges regularly. But the running cost, if you're not using the power, the running cost is not mandate. That is the advantage. But he has to pay the fixed charges by default if you're using or not using also. And also the maximum demand of the consumer is not determined. Hence, there is error in the assessment of maximum demand and the conflict between the supplier and the consumer. So here maximum demand. So each consumer has a different maximum demand. For example, I am a SSAs, for example, small scale industry, I will have one maximum demand. In case of LSA, large scale industry, that will have a one more maximum demand. So it cannot be matched. So what is the application? So it is generally applied to the industrial consumers with appreciable maximum demand, that we know already. Then the next one is the maximum demand tariff. In this also we are going to do the problem. What is it? In this tariff, the energy consumed is charged basis on the maximum demand. So what is the demand? And the unit energy consumed by him, that is known as the maximum demand. The maximum demand is calculated by maximum demand meter. So here we have to install a separate meter which is known as the maximum demand meter. This removes any conflict between the supplier and the consumer, as we were in the two-part tariff. So in the two-part tariff, one is the maximum demand plus kilowatt hour consumed, but here the tariff is charged only based on the maximum demand. So that maximum demand is measured using a maximum demand meter. So it is generally applied for the large scale consumers. And power factor tariff. So this is very very important in case of industries. When the power factor is low, it directly hit the generating station so that it will consume more active power. Uh, so that what will happen, the fuel consumption will be more. In proportion we will get more running cost. So that a power factor tariff is very very important. The power factor tariff is depend on the power factor of the load. That is a type of load I told already. I think we might have discussed in the module thing 2 or 3. That is, there are three types of load: resistive, inductive and capacitive. Resistive load is unity power factor, inductive load is lagging power factor, and capacitive load is leading power factor. If you use more inductors, that is more inductive load, that is motors, will get the lagging power factor. So it should not be. So based on the load, the power factor will change. Based on the power factor change, we will use the apply the power factor tariff. Power factor tariff is classified into two types. So one is kVA maximum demand tariff. Second one is kWh and kVA RH tariff. Okay. So here first we are going to see about one more is also there, sliding scale and average power factor. So it is okay, but these two are very very important. So the total charges, it is equal to the two-part tariff. That is, we here previous case we might have studied about the two-part tariff. That is one with the maximum demand and one with the energy consumption. So here also one with kVA, so kilovolt ampere plus energy consumption. So this is also a type of maximum demand. Here low power factor increases the kVA. If the power factor is low, what will happen? Here it will increase plus the running charges. The second one is the bill is calculated by the sum of kVRAH. So here you are talking about the uh, units consumed and the reactive power. Here we are going to talk about the active power. So this bill is calculated based on the kVARH, that is reactive power, and the kWh, that is the active power. So and one more power is the apparent power. So here that kVARH apparent power. The apparent power is inversely proportional to the power factor. So based on this, they will charge. And one more tariff is there, that is sliding scale or average power factor tariff. In this, we are taking the average power factor tariff. The particular power factor is taken as a reference, and if the power factor at the consumer end is low, then the consumer has to pay the additional charges. Similarly, the power factor of the low is above. For example, I told zero point 0.8 is considered as reference. If it is below zero point 0.8, by default they have to pay the power factor tariff in addition. If not, they don't want to pay the additional charges. Next one is the three-part tariff. In the three-part tariff, the total charge to be made on the consumer is split into three parts. So as I told already, in the name itself, it's there. One is the fixed charge, second one is semi-fixed charge, and third one is the running charge. Okay. So here A is known as the fixed charge, B is known as the semi-fixed charge, KW, or these two is known as the semi-fixed charge, and these is known as the running charge. So for example, here is the fixed charge made during each billing period. It includes depreciation, interest, the cost of the secondary distribution, and labor cost of collecting revenue. So all this will be fixed. For example, if 1,000 rupees is fixed, means it will be fixed at all times, plus B into kilowatt. So this is based on the maximum demand, charge based on the maximum. For example, 1 rupee means 1 rupee into maximum demand value. And third one is charge per kilowatt hour energy consumed. So based on the energy consumption also it is taken. So based on the fixed charges, semi-fixed charges plus running charges will give the three-part tariff. So here you can see this is the rates in increase. So I think this point we will see in next module also, that is what is the tariff available in Bangalore, okay, BBMP, and this you can have just a view in this next video. We'll see it clearly. This is also our EB bill. So this like this only we might have in provided in the BESCOM. So various factors are there. So here you can see the number is the tariff category. It has a name, and what is the load, what type of load, or what is the total consumption of load, and what is the amount calculated based on the readings, and what is the unit consumed here, and here what is the fixed charges plus tariff slabs, what do you have the tariff slabs, based on that what is your total bill. So this is a tariff for our BESCOM for a residential purpose. I think you may refer your bill also, how it is calculated. So this is about the tariff. We can see the problems in detail in the upcoming video. Thanks for watching.